Hey everyone, and welcome. Today, we're jumping into something that's, super fundamental, but often gets overlooked in data science. How we turn messy, raw data into something we can actually trust. Because without this step, even the slickest algorithm is basically flying blind. So, let's get into it.
So, here's our game plan. First up, we're going to talk about why raw data is almost always a bit of a disaster. Then, we'll get into the huge problem of missing data and look at some pretty clever ways to fill in those blanks. After that, we'll check out how to deal with those weird outliers, and finally, we'll wrap it all up by seeing why all this hard work is totally, absolutely worth it.
All right, section 1. Why is raw data just so messy? Well, just think about it for a second. Data comes from all over the place. You've got human error with typos, sensors that might glitch out, or data from completely different systems that have been smashed together. The end result is almost always a dataset full of errors, weird inconsistencies, and, big old gaps. This is the first hurdle, and it's a big one.
And look, this isn't just some neat freak exercise, right? The Business Analytics Institute puts it perfectly. This whole process is absolutely critical for building trust in what you find. Because at the end of the day, if your starting data is shaky, any decision you make based on it is going to be shaky too.
And that brings us to the golden rule of data science. Garbage in, garbage out, or GIGO for short. It's super simple, but so powerful. The quality of your analysis, your fancy machine learning models, your big insights, it's all limited by the quality of the data you feed them. You put garbage in, you're going to get garbage out, period.
Okay, let's clear something up real quick, because you'll hear these two terms a lot. You've got data cleaning, that's the fixing part. It's all about finding and correcting the problems. Then you have data preprocessing, which is the whole shebang. It includes the cleaning, but also things like transforming and restructuring the data to get it ready for a model. So cleaning is a super important step inside the bigger preprocessing job.
All right, let's dive into one of the biggest headaches in this whole process, the missing data problem. Who hasn't been there? You open up a data set and it's just full of empty cells and you're just staring at it thinking, okay, now what?
Analytics Vidya has this perfect analogy for it. It's like trying to put together a puzzle, but a bunch of the pieces are just gone. Sure, you might be able to guess what the picture is supposed to be, but you'll never be totally sure, and it's definitely not going to be accurate.
So to fix missing data, you first got to understand why it's missing. The simplest scenario is what we call missing completely at random, or MCAR. This is when data goes missing for reasons that have absolutely nothing to do with the data itself. Think of a technical glitch or, like the example says, a lab sample getting dropped. It's just bad luck.
Now, a much more common and a little trickier situation is what we call missing at random, or MAR. This is where the reason data is missing is actually connected to some other information we do have. So in this example, if we see that men are less likely to fill out a survey, the missingness is related to the gender column, which is something we can see and account for. We can work with this.
Okay, but here's the really tough one. Missing not at random, or MNAR. This is when the reason the data is missing is related to the missing value itself. So the classic example is people with very high incomes being more likely to skip the income question. This one is a real beast to deal with because it can seriously bias your results if you're not careful. So let's just break that down one more time. MCAR, purely random, bad luck. MAR, the reason it's missing is tied to other data you can see. And MNAR, the tricky one, is when the reason it's missing is because of the value itself. Figuring out which bucket your missing data falls into is the first step to choosing the right way to fix it. Okay, so that brings us to section 3. We know why data is missing, but how do we actually fix it? Well, the main toolkit for this is something called imputation. It's basically a collection of smart techniques for making educated guesses to fill in those missing pieces of our puzzle. So what is data imputation, really? It's just the process of replacing missing data with some kind of substitute value. The whole goal here is to save as much of your valuable data as possible. Instead of just deleting an entire row because one value is missing, we use what we do know to make a good guess about what we don't. You can basically split imputation into two big camps. First, there's univariate imputation. This is the simple, fast approach that only looks at the column with the missing value to make a guess. Then you have multivariate imputation. This is the smarter, more sophisticated way to do it, where it looks at all the other columns to predict the missing value. So what's the catch? Well, univariate is quick but might be too simple, while multivariate is often more accurate but takes a lot more computing power. Let's start with one of the most common tools you'll see out there, especially in libraries like scikit-learn, the simple imputer. It's exactly what it sounds like, simple, but honestly pretty effective, especially as a starting point. It just lets you pop in the mean, the median, or maybe the most frequent value from a column to fill its gaps.
And let's look at a super clear example of how this works. Okay, see that nan in feature 1? That's our missing value. So if we use the mean strategy, the imputer just looks at the other values in that column, 1 and 7, and calculates the average, which is 4, and boom, it replaces the nan with 4.0. Simple, fast, and gets the job done.
But of course, it doesn't stop there. When things get more complicated, data scientists have this whole awesome toolbox of more advanced methods. You've got things like k-nearest neighbors, which finds the most similar rows in your data and uses their values to make a guess. Or even crazier stuff like an iterative imputer, which actually trains a machine learning model just to predict the missing values based on everything else.
Okay, so we've talked about filling in the empty spots. But what about the spots that have a value, but it's just weird? That brings us to section 4, where we're going to flip the coin and talk about handling outliers and anomalies, those values that are the odd one out.
So what are outliers anyway? They're just extreme values that are way outside of what you'd normally expect. The really critical question you have to ask is, why is it an outlier? Is it a typo, like someone added an extra 0 by mistake? Or is it a real, genuine, and maybe even super important data point? Your answer to that question changes everything.
And this is a really important distinction to make, especially if you're using libraries like scikit-learn. What we're usually doing when we clean data is outlier detection. We assume our data set has flaws, and our job is to find and deal with them. Novelty detection is a bit different. That's when you assume your data is already clean, and you want to build a system that flags if any new data coming in looks strange. So think of it this way. One is about cleaning up your past data, the other is about keeping an eye on the future.
All right, this brings us to our final and maybe most important section, the payoff. After all this detailed, sometimes frustrating work, why do we bother? What's the big reward for getting your data preprocessed just right?
Get this. This statistic is pretty mind-blowing. A lot of data professionals spend a whopping 70 to 80% of their time just on cleaning and prepping data. This isn't just a side quest, folks. For many projects, it is the main event. And there's a very, very good reason for that.
Because the benefits are huge. When your data is clean, your models just perform better. They're more accurate, more reliable. You cut down on noise and potential bias. It helps you find better insights. And maybe the biggest thing of all, it builds trust. When you can stand by your data, everyone from your team to your boss has more confidence in the results.
So I want to leave you with one last thing to think about. When you think about all the stats, all the coding tools, and then add in that human intuition you need to decide if an outlier is a mistake or a miracle, is data cleaning really more of an art or is it a science? Something to chew on. Thanks for tuning in.